Now let's see how we can create objects or resources in RESTful terms. So we're going to send a post request to the user's endpoint. And in the body of the request, we're going to include a valid user object. So we should include the name, the email, and the password. Back to our controller. Now we have a problem. In this method, we are receiving a user DTO object. In this class, we don't have the password field. We had it earlier, but we had to remove it because our passwords were leaking outside of our APIs. Now you might be wondering if we can add the password field here, private string password, and annotate it with JSON ignore. This is not going to solve our problem because this annotation is applied both during serialization and deserialization. So that means if you have this annotation here, Spring will not read the password property of our JSON objects and put it into this DTO, okay? So this is not going to solve our problem. Earlier, we talked about the architecture of our application. I told you that our entities are at the heart of our application and API models or DTOs are at the boundary. With this separation, we allow the DTOs and entities to evolve independently. Here's another example where we need a separate DTO for creating new users. In that DTO, we're going to have the password field, and also we are not going to have the ID field. This is not needed when creating a new user object, right? So back to our project. Here in the DTOs package, let's add a new class. We can call this register user DTO. Alternatively, we can replace DTO with request. That's another convention a lot of people follow. This better aligns with the request response model of HTTP. So this class essentially encapsulates all the data we need for sending a request to register a new user. What fields do we need? We need the name, the email, and the password, and not the ID field, right? Now, we should annotate this with getter and setter, so Spring can initialize these fields using the request data. Alternatively, we can apply the data annotation, which is the combination of getter, setter, toString, and toHashCode. It makes our code a little bit cleaner. Now up here, let's remove the unused import statements. Good. So we have 3 fields. Now we need to provide the mapping between our new DTO and user entity. And for that, we go to our user mapper interface. Here we add a new method that returns a user object. We can call that toEntity and give it a register user request object. Okay. Now let's go back to our controller and change the type of the parameter to register user request. And for consistency, I would prefer to rename the parameter to request as well. Now at this point, we don't want to return the same request. So let's return null. We'll come back to this momentarily. First, let's map this request to a user entity, print that entity on the terminal, and make sure everything works up to this point before going further. So always do one baby step at a time. So here we call mapper.toEntity and provide the request object. We get a user and then print it on the terminal. Now let's go to our user class and see if we have the toString annotation. We don't have it here, so let's add it temporarily. Now IntelliJ is suggesting to exclude lazy loaded fields. This is for performance reasons. We talked about this in the first part of the course. Let's just go ahead with the suggestion. Again, this is just a temporary solution. We just want to inspect the user object in the terminal before saving it to the database. So let's restart the application and send this request. All right, obviously we don't see anything in the response. The status is 200, which means no error happened. Now here in the terminal, we have this user object. ID is null, obviously, because we haven't provided it, but we have the name and email fields. Where is password? Well, I just realized that in part 1 of the course, we implemented the toString method in this class. So it's right here. We didn't have to apply the toString annotation. In this implementation, we are not including the password. Again, as a temporary solution, I just want to add the password here. So let's set password to password. And before we forget, let's remove the toString annotation on the top. Not needed. Let's restart the application and send this request. Okay. Now look in the terminal. All right, here's the password. So our mapping is working properly. Now, before going forward, I want to undo the changes we made to the user class. So we go to the commit window, select the user class, and roll back the changes. Okay. Now, back to our controller. Once we have a user, we can save it using our repository. So user repository.save user. The database will assign the ID to this user. Next, we should map that to a user detail and return it from this method. So we can create a user detail by calling usermapper.toDetail and then return it at the end. Now, IntelliJ is suggesting that this local variable is redundant. We can combine these two lines. That's absolutely right, but don't do this yet. We're going to come back to this momentarily. Let's restart the application and make sure that we can successfully save the user to the database. So send. All right, here's a new user with the ID of 3. Currently, our database doesn't have a unique constraint on the email, so we can register multiple users with the same email. That's not the right way to do it. We'll come back and fix this in the future. But what I want to point out is that every time we send this request, we get a new user with a different ID. Beautiful. Now, there is one more piece that we have to implement before we finish this. When creating resources in REST APIs, we should set the status to 201, which means created. To do that, we have to change the return type of this method to response entity. And then at the end, we call response entity.created. Now look at the parameter of this method. It requires a URI. This is the location of the new object or the new resource that is created. So if you have a user with the ID of 5, that's going to be users/5. Now, how can we generate that URL? Well, back to this method. Let me put this on a new line so you can see clearly. We're going to give this a second parameter of type URI components builder. Components builder. Now, let's simplify the name of the parameter. Let's change it to URI builder. That's better. Now, once we map this user to a DTO, we can call URI builder.path, provide the path to our resource, so /users/ID as a parameter, and then we call build and expand and provide the ID of the new user as an argument. And finally, we call .toURI. Let's press tab. This returns a URI object. We can store it here. And then at the end, we call response entity.created. We pass the URI. Now, this method returns a body builder. Funny name. It's not a response entity. To convert this to a response entity, we call .body and provide our user detail in the body of the response. User detail. Okay. Now, let's restart the application and see what happens. So let's create one more user. All right, this time we got the status of 201. Now look in the headers tab. So HTTP responses, just like requests, also have headers. Here we have a header that is location. It's a standard HTTP header. And this is set to the URL of the new resource or new user. Now, quite frankly, a lot of people don't implement this step. They don't set the status to 201. So here we could get away with generating the URI and simply return the user DTO. That's totally fine for internal APIs. But if you're building an API for public to use, it's best to follow standard REST conventions.